Hello, this is just follow up about the remesh. If you do not have wavebirds, you can still be able to generate the frame system based on every single edge. So I will show you really quick how you can do this step by step. So assuming you already have, let me just do show this mesh geometry, right? This is the result from the remesh, and you can see all the um, tessellation now is adapted to the new shape after booling. So if I want to create, for example, very similar like the lattice function in 3ds Max, right? I want to create a frame based on every single edge of these faces, like lattice. I can do this by loading the mesh into Grasshopper. So I can take this mesh in. So now this mesh is a part of Grasshopper environment. Then I can use the tools under the mesh, and here you can extract edges from the mesh. So if you plug in, you can see it's generate E1, E2, E3. E2 is the shared edges. So here you can see you have 1606 total edges. E1 is empty because there's no naked edges here. E3 is empty. All right, so let's go ahead. There's a quick way you can do pipe, but I don't really recommend to do this one. The reason is it just generate a lot of tubes based on your model. The tube is not really efficient when you do the real-time renderings. Right, you gotta, you know, uh, reduce the rendering time. So instead of using the tube, it's very similar like the lattice. I will download a script. This script is actually from my earlier, if you know the frame modeling in Grasshopper, which you probably already know, which is under the tutorial. This is the, frame modeling in Grasshopper. So if you drag all the way down, you can see this version 3 allow you to create some frames not based on the circular profile, but it's rectangular or any profile you can define. All right, so you can go ahead, download the Grasshopper file, unzip. After unzip, I can go ahead, open the Grasshopper. So I already did this a few minutes ago, so it's right here, frame tectonic. So I only need to borrow this portion of the script. This basically take a sequence of lines, right? And then you create a profile based on this polyline. Then you have this frame, then you convert frame into a mesh. So to use it, I can just simply Control C, copy. Then I can go to my new script. Right here, I can Control V to paste. Later, I will just simply share the file for you, so you can have this in my tutorial. All right, so here you just simply need to plug in the E2 into C, right? So that's basically generate all the lines. This will take like several seconds because it's computing. You have 1,600 lines, so it will take a little bit time. Although it's slow, but the result is very clean, right? You don't have to worry about the pipes in the future. So here, if I reopen Grasshopper, right, and I probably want to bouncing up the radius, because this one probably the unit is I don't know, centimeters or millimeters rather than meter. But anyway, I can bouncing up this value, and you should be able to see the result right here, right? So this is a much better version compared to the pipes. And here, if I go ahead, bake it, let's bake in level 5, right? And then close Grasshopper. And you can see if I turn off the original one, okay, so you can see this new frame system is really nice. It's all based on the rectangular shape, right? Okay, so you might want to think about this as an alternative way to create a frame system, not using the wavebird, right, to do the skin or the blobby shape, but rather create this very smooth, rigid frame system. But there's one limitation you have to think about is in order to fabricate this, right? If you look at this whole system has to make a lot of joints. These joints has to be able to receive the angled frames. So the frame is not like a perpendicular to it. If I check this from top view, you will get what I mean. Is the frame is not necessarily like a straight line, right? It's a curved line. If you do want to have a straight line, you probably want to use the contours, right, to create this sequential frame rather than using the remesh, because remesh will automatically bend these frames when it's getting closer to the edges, to the round corner, or to any boolean openings. So there's the pros and the cons using this script. But if you do want to create some really cool wood joints, and here you can connect this four from different angle, you can definitely do it in a kind of batched way, maybe prefab in a factory. Then you can assemble that on site. It gives you this beautiful smooth mesh tessellation. All right, I think that's it. I will share this script to you later, and yeah, play with it.